to watch what's happening here. There's not even any talking. There's just some text that goes with it, but it's going to do a great job of showing you synchronous rotation. Okay, so notice, if it didn't rotate, we would see both sides of the moon. Okay, the red side represents, there we go. Okay, so we would see both sides if it didn't rotate. With rotation, we might also see all of the sides of the moon. So it's not just that it rotates. The key is that its rotation speed has to be equal to its revolution speed. That was way too quickly. But now if you look, if it's rotating ever so slowly at the same speed at which it is revolving, look at how that red side always faces the Earth. There it is one more time. It almost appears like it's not rotating, but it is. Think back to that first example they gave us when it wasn't rotating, how we saw both the red and the white side of the moon. So it's ever so slowly turning and rotating as it revolves. That's synchronous rotation. Okay, so now you see it with the shadow as well, so that you can see how we see the different phases. There's your full moon. Here's your third quarter, waning crescent, and then back to a new moon. Synchronous rotation. All right, so that's usually a pretty big misconception. That's usually one of the few things in this unit that is brand new for you guys to learn, is this idea of synchronous rotation. So that's important, so make sure you know that. All right, let's go through the phases. First, the words sometimes are a little bit weird, so I'm sure you've heard these before as you studied the moon before, but let's just refresh them. The new moon, the moon's not illuminated side is facing the Earth. Okay, so it almost appears like there's no moon in the sky. 0% is illuminated. The opposite of that is when it's on the other side, and it's a full moon. And the illuminated side is completely facing the Earth, so we would say that it's 100% illuminated, like it's showing in my background picture. Quarter half is 1/2. 50% of the moon appears to be illuminated by sunlight. So we have that quarter moon, the first quarter, and then the third quarter. Okay, or sorry, the first quarter and the last quarter, I should say. Sometimes they call it the fourth quarter. Okay, pause if you need to finish typing those in before you go to the next slide. All right, moving on. More definitions. Waxing phases. When something is waxing, that means that there's a little bit of more illumination of the moon each night. So it's almost like the moon is growing a little bit more every single night. That's the waxing phases. Waning phases. It's the opposite. When something is waning, that means it's becoming less. And that word waning is actually used a little bit more in the English language than waxing. As we are getting towards the end of the school year, we might say that the school year is waning. Okay? Sometimes your parents' patience might be waning, especially when you're home all day, every single minute. Their patience might be waning. It's becoming less. Okay, so it's almost like the moon is fading away or disappearing for waning. So waxing happens before full moon. Waning happens after the full moon. Couple more. Pause whenever you need to. The gibbous phases. Gibbous phases, gibbous means swollen, and so what that means is that we're talking about a little bit more than half of the moon is illuminated, okay, but not all of it. Okay, so it could be, that could be a couple different days where that happens. Same thing with the crescent phases. It's less than half, but obviously it's more than none, okay? So think of that small little crescent like a fingernail or a crescent roll. Pause the video if you need time to type these in before we move on. Okay, so here it is, seen from Earth. So nothing for you to type here, as we just kind of go through this. So imagine here you're on Earth, because that's where you are. So here's what new moon would look like when you looked up in the sky. You wouldn't see anything. For a waxing crescent, when you look up the sky, you would see just a sliver of the moon, but it's important to recognize, well, which side is illuminated, the right side or the left side. When the right side is illuminated, that means it's waxing. Okay, when it's the right side's illuminated, it's waxing. So you have a waxing crescent, grows a little bit more, and then you can have half illuminated on the right side. So that means that it's the first quarter. Then that continues to grow and grow and grow and grow, and then you get to this phase called the waxing gibbous phase. Again, it's on the right, and it's more than half. And sometimes waxing gibbous can be a little bit confusing because it almost looks like a full moon in the sky. But it's, there's just a sliver that's not showing, that's still in a shadow, so it's not completely a full moon. Full moon we're all familiar with. Okay? All right, so now on the other side here is where we start looking at the gibbous, third quarter, and crescent for waning phases. And so when you look up in the sky here, it would be on the left. Okay, it's going to be on the left. So I know this starts to get confusing because you're like, well, wait a minute. If I'm here, doesn't that mean it's still on the right because I'm here? No, this is the way how it's going to appear to you. So it's on the left that's illuminated. And it's less than full, but not half. Half comes when we get to the third quarter. And it's again on the left. And then the waning crescent is when it is that little sliver, again on the left, and then it disappears all the way to new moon. All right, so what are the causes for these moon phases? Well, first of all, the reason that the moon is even illuminated is important to know. The moon does not have its own power source. It is literally reflecting the light from the sun. Okay, so if the light from the sun reflects off the surface of the moon, if something blocks that path of light, we're going to have a shadow. And that's what's going to cause those different phases, is that the relationship between where the sun is, the earth is, and the moon is, there's going to be some shadows that pop onto the moon. Okay? So like we said, 50% of the moon is always illuminated by the sun because there's always half of it facing the sun. We just don't always see that. Okay. Revolution of the moon around the earth changes the relative position of the moon to the earth and to the sun. And that's what causes us to have these phases. They depend on the amount of sunlight that is facing the earth. Okay, how much sunlight is hitting the moon and reflecting on that side that is facing the earth. Okay, pause this if you need to as we move on. Okay. So this is what it looks like if we weren't on Earth and we were just standing out and we're on like the International Space Station or something. This is what we would see. We wouldn't see the phases, okay, because we're not going to see the shadows. We're always going to see some 50% of the moon illuminated. And the difference comes into when you're on Earth. Now the Earth is going to block some of that light sometimes. And so we're going to have phases based off of those shadows. Aspects of the moon phases. All right, when the moon is in any position on the daylight side of the Earth, less than 50% is illuminated. So that would be the crescent phases and the new moon phases. That usually means that up in the sky, those phases are present more so during the day than they are at night. It doesn't mean that they're not up at night at all. Okay, but that usually means that the majority of their time is up during the day. Obviously, daylight savings affects that because sometimes it's dark by 5 o'clock, and sometimes it's not dark until 9 o'clock, and so that also kind of affects whether you're seeing it in the night sky or in the evening sky or even in the late afternoon sky. There we go. Like I said, new moon and crescent phases. Oh, let me go ahead and pause that. I'll give you a chance there. Pause that, type that in before I show you how that happens. All right, so if you look, phases here, 4, 5. Oops, I'm sorry, sunlight's over here. Phases 1, 2, and 8. So look at 1, 2, and 8. Those are the ones that are on this side. Look at this is Earth. This is the daylight side of Earth. The daytime side of Earth. So these are the phases that occur during that are usually up in the day. You still can see them at night, but they're usually up mostly during the day. Okay. You guys know that our calendar is based off of the lunar cycle, and it's approximately 4 weeks. It takes approximately 1 week to go from one major phase to the next. So what I mean by a major phase is when we say new moon to crescent moon, okay, or new moon. I should say new moon to quarter moon. I should say new moon to quarter moon, and then quarter moon to full moon to last quarter, and then last quarter back to new moon. Those are the main phases that we usually speak of. Those major phases. 1 week to go from one to the next. Okay? So, one last thing as we're finishing the notes here. You might be asking, well, wait a minute. If the rotation in revolution is 27.3 days, how come our months are 30 or 31 days? Well, to be honest with you, it's because even though it only takes 27.3 days for the moon to rotate around Earth, because of the different times of when we see the phases and the moon rise and set, there's times when it can rise on one day and set on the next day. It doesn't rise and set within the same days. So for instance, maybe it rises late, like at 9:30 at night, and then it sets at 3 a.m. Well, technically, that's the next day. And so that's where sometimes we pick up these extra days, if you will. And so a whole lunar cycle is actually 29 and a half days. 29 and a half days, not 27.3. Okay? And it's because of that. It's because of the moon, when it rises and when it sets. Sometimes those are on 2 different days because it happens past midnight. And even though we usually just consider that still to be nighttime, technically it's the next day once you get past midnight. And so that's why you pick up a little bit of that extra time. So 29 and a half days to go through that whole lunar cycle. And that's why our months are about 30 to 31 days. Okay, that takes us through the notes. I know that was kind of a lot, but again, that's the only notes for this, for the phases. Use this to help you if you are deciding to do the digital project for Tuesday and Wednesday and Thursday. Watch that video to understand exactly what it is that you're going to be doing, but these notes can help you. The only thing that I don't have on here is I don't have pictures of those moon phases, and you need to be able to recognize those. So you're going to want to do some Google image searches for those. All right. That's the end of the video and the end of the notes. Talk to you later.